As a customer service agent at SeaPort, one of your responsibilities is to produce an accurate manifest for every departing flight. This is important not only for the safety, but also for the legality of each flight. Every manifest is a legal document and should be prepared with care as such. You have a direct role in the safety and legality of each departing flight. Before we dive into producing an accurate manifest, it helps to understand the fundamentals of weight and balance as a function of both safety and legality. For this, we intend to give you the tools that pilots use in their initial training. The principles of both weight and balance can be addressed separately, even though they're equally both important to safety of flight. When considering weight, an overloaded aircraft is an unsafe condition because it produces a multitude of undesirable effects for flight and maneuverability. In fact, an overloaded airplane can negatively affect every aspect of flight. These include higher takeoff speed, longer takeoff run, reduced rate of climb, lower maximum altitude, shorter range, reduced cruising speed, reduced maneuverability, higher stalling speed, faster approach and landing speed, longer landing roll, excessive weight on the landing gear, and in the case of our Cessna Caravan aircraft, inability to maintain altitude and airspeed in flight ice conditions. In addition to this, it is important to note that as an aircraft flies, it also loses weight as it burns fuel. A typical flight at SeaPort can burn 350 to 400 pounds for one leg of a trip alone. Balance is also important, mainly to the stability of an aircraft. When we talk about balance, we're referring to the center of gravity of the aircraft. On Earth, everything has a center of gravity. You and I have a center of gravity. The center of gravity is a point at where the majority of the mass is concentrated and is the point of equilibrium from pretty much any position. My center of gravity is right about here, as it is for most humans. Here's a miniature teeter-totter, much like the one you might have played on when you were younger. Right now, it's in its balance above the supporting triangular block. This point is known as the fulcrum or datum. It is level and resting at its center of gravity. So, once again, we have our lever and our fulcrum. Now, for purposes of this demonstration, the lever is a ruler, as you can see. It's resting at its center of gravity of 5.5 inches. So, let's pretend that this is an aircraft. At this end, we have the nose, and at this end, we have the tail. And we're going to take our aircraft to North Bend today. So we have to have fuel. Let's add fuel. Well, that moved the center of gravity in this direction, forward. So let's move our aircraft, find its center of gravity again. That's about 5 3/4 inches it moved in that direction. All right, well, we need pilots. I'm not going anywhere without them. And, well, that shifted our center of gravity forward again. So let's have a look here. Move it forward. That's about 6 1/4 inches, just a little more than 6 1/4 inches. Well, we need our golf bags. We're going to North Bend, so we have to have golf bags. Put those there, and we'll take some passengers along. There we go. We'll have to move our center of gravity back a little bit now. Well, that's just a little bit less than 6 1/4 inches. But we have one late passenger, and we have to recenter again. So let's have a look here. And that's about 6 inches even. So you can see how even changing the slightest little item on an aircraft, or moving something forward or back, can drastically change the center of gravity, the balance of an aircraft. When we talk about the center of gravity, or CG, of an aircraft, we've been referring to its longitudinal axis, front to back. By loading passengers, bags, fuel, we have the largest effect on this axis. The lateral axis along the wing is not as critical, but it can also be a concern if, say, there's a fuel imbalance. Primarily, though, our focus is on the location of the CG forward to back when making calculations for weight and balance. Just like our teeter-totter, every aircraft has a lever and fulcrum, or datum and arm as it is called in aviation. The fulcrum, for purposes of calculating weight and balance, is usually the tip of the nose of the aircraft. The center of gravity is measured in decimal inches from this point to the tail. For example, pilot seats are located at 135.5 inches from the datum, or nose, of the aircraft. Row 6 is located at 281.9 inches after the datum. The baggage in Pod C is at an average of 233.4 inches after the datum, and so on. To calculate the center of gravity, we simply average these weights across the entire aircraft, at which we arrive at the center of gravity, or CG, for this load. The average must then fall between the manufacturer's specifications for maximum forward and maximum aft CG limits. On the Caravan, these are between 179.6 inches and 204.35 inches after the datum. Quite a narrow window considering we can load people, fuel, and cargo from 118 to 356 inches along our lever. There is an easy way to view our weight and balance calculation results by using what is called a weight and balance envelope. At the left of our envelope, we have a forward center of gravity limit of 179.6, and at our right, our aft limit of 204.35. At the bottom is the lowest possible empty weight of the airplane at 4,000 pounds, and at the top is the maximum gross weight. Horizontally, we can see balance, and vertically, we can see weight. The center of gravity, or CG, is represented as a dot at any point inside this envelope. If it remains inside the envelope, the aircraft is considered to be within the specified limits of the manufacturer. If it is outside, the aircraft is not within specified limitations and is not safe or legal for flight. So now that we have a rudimentary way to measure weight and balance, let's see how we can actually calculate a real weight and balance.
With any weight and balance, we must first start with the airplane itself. Here I'm standing at the Echo parking spots at PDX between two aircraft, 26 Victor over here and 24 Mike Golf over there. Now these are seemingly two identical aircraft. They both look identical. They have the same maximum gross capacity. They were probably manufactured in the same plant. In the world of weight and balance, however, they're very different. That's because each of these aircraft is put on a special scale that measures the weight on all three wheels and the difference between them to determine the empty weight and the center of gravity. This is the weight with no fuel, bags, passengers, or pilots.
Now that we know each aircraft has its own unique empty weight, we have all the information we need to begin a real weight and balance calculation. So let's get started. So we'll begin with our formula. Will be weight multiplied by arm. Remember, that's the number of inches after the datum of each item. And our result we'll call the moment. So, as we begin, start with the empty weight and center of gravity of the aircraft, which is 5,263.6 pounds, and the center of gravity is 191 inches aft of the datum. Multiply these two together, 5,263.6 times 191.0, that gives us 1,005,347.6, and that's the aircraft. Next, let's add fuel. We'll do 1,400 pounds of fuel. And the fuel will be located at 204.6 inches aft of the datum. That gives us a moment, multiplied together, of course, of 286,443.22. Now, let's add passengers. Oh, no, we have to add pilots first. Not going anywhere without them. Now, see, since the pilots sit in the same area after the datum, we'll simply add their weights together. So both of our pilots together weigh 375 pounds, and they sit at 135.5 inches after the datum. Multiplied together, we get the moment of 50,812.5. Now we can add passengers. We have one passenger in row 1 at 120 pounds. Row 1 is located 181.9 inches after the datum. That gives us a result of 21,828 even. Passenger 2 weighs 151 pounds. And their seat is row 3, which is located 221.9 inches after the datum on this aircraft. And that gives us a total of 33,506.9. Passenger 3, our heaviest passenger in the back, 220 pounds, at 281.9 inches after the datum. That's at row 6, the last seat, at 62,18.0. And finally, they have to carry bags, so we'll put our bags in pod C, which is pretty standard. So we'll put pod C there. We have 115 pounds of bags in pod C, which is 233.4 inches after the datum, and that gives us a result of 26,841 even. Now, our object is to add all of the weights and add all of the moments. And we'll start with the weight. At the ramp, we will have a weight of 7,644.6 pounds. And once we add all the moments together, we get the enormous number of 1,486,797.22. 1,486,797.22. Now, to get our arm, or center of gravity, of all of these in the average, we divide our moment by weight. So total moment divided by total weight will give us our CG. and that comes to 194.49. Now that we have this number, we can go back to our handy weight and balance envelope we saw earlier. Now we'll start with the weight, and we see it's 7,644. So I'm going to move up the scale. The weight is on this side, and there's 7,500. Next hatch mark is 7,600, so it's just a little bit more than that. We'll draw a line. Okay. Now we have our center of gravity, which is 194.49, so 194.5. Well, here's 195 right here. So let's put straight edge right along 194.5. Draw a line. Where they intersect is in the envelope, and right here, where they intersect is our center of gravity. It's in the envelope, so we are legal to fly. And that's it. We have now determined that we can safely and legally operate this aircraft by manually calculating the weight and position of all of the fuel, bags, passengers, and cargo, and how they affect the center of gravity. Luckily, though, for customer service agents, you have an electronic manifest that does all the calculations. All you must do is simply plug in the information. With any manifest, our data we need to plug in begins at the ticket counter.
Here's your ticket, Mr. Hyson.
Thanks.
Listen, I hate to ask you this, but we have a full flight today, plus a lot of extra baggage, so for safety's sake, I really need to know your exact weight.
Sure. 165.
Okay. And while that vertically striped shirt certainly does flatter you, you really have to ask yourself, do I want to tell the truth, or do I want to cling to this futile sense of vanity and be responsible for a plane load of very nice people plunging into the Atlantic?
Okay. 190. 7.
Fine, you're under the limit. Good thing you're not 220.
I'll take the next flight.
When obtaining weights of passengers and baggage, the company and the FAA have specific guidelines on the procedures in doing so. They're contained in a document called the GOM, or General Operations Manual. This manual contains all company procedures for operations with regard to meeting our operation specifications established by the FAA. Every airline has its own set of operation specifications, or OPSPECs, approved by the FAA. Every commuter or charter airline also has a General Operations Manual that lays out the procedures for meeting the OPSPECs, and is also reviewed and approved by the FAA. Section B of our General Operations Manual outlines the specific procedures for acquiring passenger, baggage, and cargo weights. Numbered procedures 4 through 8 in the weight and balance procedures dictate how CSAs shall determine weight, beginning with number 4, which states, the weight of each passenger will be determined by weighing each passenger or asking his or her weight. 10 pounds shall be added to the passenger's asked weight. If the weight that is given is understated, a reasonable estimate of the passenger's actual weight plus 10 pounds can be used. Number 5. The actual weight of the crew and their baggage will be used. Number 6. The weight of all checked baggage will be determined by actually weighing each item. Number 7. The weight of all carry-on items, including personal items, will be determined by actually weighing each item. And finally, number 8. Cargo weight will be determined by actually weighing each item or may be taken from the bill of lading. If the bill of lading appears to be unreliable, then the item will be weighed. If several items are included in one package, the total weight of the package may be used. Before us is an empty manifest form made in Microsoft Excel for the entire fleet of SeaPort aircraft. We begin by selecting the Excel page that has the aircraft type for which you are preparing the manifest. For this example, we're preparing a manifest for November 1026 Victor, which is on the Heavy Van 2 worksheet. Before proceeding further, verify at the bottom of the page that this is the most up-to-date version of the manifest file. Now we know this is a current file, we can begin by filling in the information from top to bottom of the sheet. A helpful hint for this is to fill out anything in red on the sheet, as items flagged in red signal our attention is needed. At the top, we select the aircraft, 1026 Victor. Moving down, we can add the flight number, the origin, and destination. Next, we add crew from the pre-selected list. Sometimes in the case of new employees that are not on the pre-selected list, it is necessary to manually input the name and weight in the custom flight setup box to the right. Notice that you must input the weight for this, whereas the pre-selected list automatically adds pre-programmed weights of the crew to the manifest. It's now time to add our passengers, their luggage, and hand-carried items to the manifest. Before we begin this, let's go back to our weight and balance envelope for some guidelines on loading. Notice how the envelope is wedge-shaped. As such, with the forward CG limit at the left and the aft CG limit at the right, we're allowed a higher limit of weight to load the further aft we place it. Because of this characteristic, it is best to begin loading from the back of the aircraft forward, with the heaviest weights aft and the lightest forward. Referencing the data entered into the reservation software, we can find our passenger weights, and referencing the check-in software, we can find our passenger baggage weights. Our most heaviest passenger we saw earlier is Mr. Hyson at 220. We'll add 10 for a total of 230. We can place him in the single seat at row 6. He also has a golf bag weighing in at 50 pounds and luggage at 30 pounds. Additionally, he has a laptop carry-on weighing in at 20 pounds. He plans to put it in the black storage box in the back of the aircraft. We add all of these together and have a total of 100 pounds for luggage. Next is Angus Fittwilder, a businessman and golfer. He weighs 170 pounds, is carrying a golf bag of 50 pounds, and a gate-checked carry-on at 15 pounds. So our total for his bags is 65 pounds. We'll put him in row 5. Next is Marietta Klanowski. She weighs 125, has a lap-carried handbag of 5 pounds, and a 40-pound check bag. We'll put her in row 4. Finally is our last passenger and frequent flyer, local curmudgeon Claudia Fussmacher. Mrs. Fussmacher is elderly and frail, but she insists on sitting in the front seats where she can keep an eye on things. We humor her because she only weighs 110 pounds. She has a large handbag of 10 pounds where her pet toy breed dog resides, exclusively, or so our best sources say. Alongside, she brings 2 large bags weighing in at 115 pounds total. As requested, we can put her in row 1 as long as we are within CG. That's it for passengers. Now let's assign bags. As with passengers, we should try to load the heaviest weights in the back. Our golf bags are nearly the heaviest, but they don't fit well in Pod C, so we'll place them in Pod B where they'll fit better. If that doesn't work, Pod D works in a pinch. So we place 100 pounds in Pod B. We should be able to fit the rest in Pod C and be within the limit of 270 pounds. We have Mrs. Fussmacher's bags at 115, plus Marietta's bag at 40, Mr. Fittwilder's bag at 15, and Mr. Hyson's bag at 30 for a total of 200 pounds in Pod C. Looking further down, we can see a red flagged item next to the unassigned cargo weight. It says we've neglected to assign 20 pounds. Looking back above, we remember Mr. Hyson's 20-pound carry-on. He wishes to place it in the black carry-on box in the aft cargo area, rather than hold it on his lap. So we'll put the 20-pound weight in the aft cargo box, and that fixes it. All of our cargo weight is accounted for. Next, we'll add fuel. The captain wants 1,400 pounds and told us the expected fuel burn is 400. And now for plugging in our data, we're finished. Time to verify. Scrolling down, we see that for takeoff and landing, the aircraft will be in CG. Below is our envelope with the takeoff and landing weights and CGs plotted for us. One extra thing to note about this envelope. Notice the line above. That is the maximum ice weight for the Cessna Caravan. Should our weight be anywhere above that line, a yellow flag will light in the warning box that lets us know the aircraft is too heavy to safely fly in ice conditions. If our weight is in this zone, simply notify one of the pilots. They can depart if there is no ice, and if there is ice expected, they can adjust the load to be under the limit by limiting bags or fuel. Once the manifest is reviewed and deemed accurate, we print 2 copies, one for the captain and one for our records on the ground. While what we just saw may seem a small task in the plethora of responsibilities as a customer service agent, it is one of your most important. Manifests and weight and balance are just one of the many roles you play, making our company safe and successful.